Welcome to AMK Resource World. Your success, our motto. In this video, we are going to learn to solve problems on Zener Diode as a voltage regulator. Okay, let's have a look with a problem on Zener Diode. So here we have a problem. Let us solve this. So the problem is like this. They have given a Zener Diode in this circuit, and also they have given the Zener pecton voltage, that is Vz is equal to 10, and they have given the value of the resistance as well as the input voltage, range of the input voltage, that is between 20 to 40 volts. And what they are asking, what we need to find in this problem. So they are asking, find the minimum and maximum Zener currents, that is Iz min and Iz max. We need to find that. So let us do this. By observing this circuit, we come to know that this is a circuit for voltage regulator with Zener diode with no load. So already we have discussed we can have Zener diode as a voltage regulator with load and without load circuit. So this is without load circuit. So therefore already we know that as it is with no load, Is, the current flowing through this resistor Rs, is equal to Iz here, which is equal to Vi minus Vz by Rs. So here, if I put max here, then Is max is equal to Iz max. So when I am calculating Iz max, at that time I need to substitute maximum input voltage value, that is Vi max. So here, after substituting the maximum value of the input, which is already given in the circuit, that is 40 here. So 40 minus Vz is 10 here. We are substituting. The value of Rs is 820. So once we substitute and calculate this, so we are getting 36.6 milliamperes. That is the maximum Zener current that flows in this circuit. Whereas similarly, we can find out the minimum Zener current, that is Iz min, from the same equation. So Is min is nothing but Iz min, which is nothing but Vi min minus Vz by Rs. By substituting the value of Vi min, that is the minimum input voltage is 20 here. So 20 minus Vz is 10 here by 820, that is your resistance value. And if you solve this, we are going to get 12.2 milliamperes. So this is our Iz min. So this is what they have asked here to compute, to calculate in this problem. So we have seen here how this can be calculated. So we have obtained the minimum and maximum Zener currents for the circuit given here. Let's go with another problem. Here you can see we have a problem. In this they have given the circuit and they are asking to find IL, that is the load current, Iz, that is the current through the Zener diode current, and they are asking to find the power dissipation through this Rs resistance, power dissipation through this RL load resistance, and Pz, that is the power dissipation through this Zener diode. So let us calculate and find these values for this problem. So before we calculate, first we'll just write down the given data from the circuit here. So Rs is 270 ohm, RL is 1k ohm, and Vi they have given 18 volts, and Vz they have given 10 volts. Fine. So we know that already we have these equations with respect to Zener diode as a voltage regulator. So Is is given by Vi minus Vz by Rs. Or else you can write from here. So the voltage here is Vi. The voltage at this end of the resistor is Vz. So Vi minus Vz by Rs, that is your Is. So Is is nothing but Vi minus Vz by Rs. So by substituting the values of this, which we already know. So if you substitute here and if you simplify, we are going to get 29.62 milliamperes. This is the current Is we got after calculating. Now similarly, we know that IL, what is IL? It is a load current. So I is nothing but V by R. So if you know the voltage across the load and if you know the load resistance, then we can put here. So the voltage across the load is equal to the voltage across the Zener diode, the voltage drop across the Zener diode, because this is a voltage regulator circuit. So VL is nothing but Vz. So IL is nothing but Vz by RL. So therefore, by substituting the values of this Vz and RL, we get IL as 10 milliamperes. And we know for a circuit with load, a voltage regulator circuit with load, IS is nothing but sum of IZ and IL. So if IS is equal to IZ plus IL, then IZ is nothing but IS minus IL. So again, by putting the values of this IS and IL, which we have already computed here, we get the value for this Zener current, the current through the Zener diode, that is 19.62 milliamperes. And next, what we need to find is the power dissipation through RS and the power dissipation through RL and the power dissipation through the Zener diode. So we know the formula for power, that is power is given by R into I square R, P is equal to I square R. So here to find the power dissipation at resistance RS, PRS, it is given by RS into IS square. So already we know the value of RS and we know IS. Then substituting here, we get this value. Similarly, we have a formula for power, that is V into I. So to find PZ, we can write Vz into Iz. We know Vz and we have calculated Iz. So substituting this, we got PZ, the power dissipation through the Zener diode. And finding the power dissipation through this load resistance, that is RL into IL square. So substitute the value of RL and IL, then simplify, we are going to get this much value. So here we have solved a simple problem where they have given a Zener diode voltage regulator circuit with load and they have asked to calculate these things, and we have calculated this. Guys, if you like our video, please like, share and subscribe. We will be bringing more such videos relevant to your topics in our channel AMK Resource World. Your success, our motto.